Alright, looking at the first day of chapter 12.6, this is a 2-day lesson, and we actually are going to work tomorrow, so come in tomorrow with your work information and things, because we're not taking a quiz on this. We have to move since we do have a break after next week. I cannot move this beyond spring break, so we have to fit that in. Other than that, talking about permutations and combinations, this is really what you're writing there. Permutation is an arrangement of n objects. So the number of objects here would be 3, and you're just arranging 3 objects in different ways. Arrangements can't be planned by multiplying options in blanks. That is something we're going to see here in terms of what's going on. And again, after you write this down, go ahead and unpause your video so that I can get to problem 1. Problem 1 is talking about you're shopping for a new car. It comes in 4 different colors, 7 different interior patterns, option for 2-door or 4-door. So when you're talking about a permutation, how many different ways you can design the car, you're talking about how many choices you're making. The first thing you're choosing is the color. So that's one blank I would put down because that's a choice I'm going to make. Then you also have interior patterns. So that's going to be a choice I make. I also have an option for 2-door or 4-door, which is a third choice that I am going to make. So there are 3 choices I'm going to make. Now I have to find out how many choices per. When I look at my colors, I have 4 different colors to choose from. I have 7 different interior patterns, and then I either have 2-door or 4-door, which is 2 options on that, and all you have to do for your permutation or for your numbers is multiply those 3 numbers together to get your answer, to get the answer of 56. That's it. Alright, that's how easy it is. The hardest part is figuring out how many blanks to put down, but that would tell you how many choices that you're making when you're doing that. So you might have to reread the problem a couple times to determine how many blanks to put down, but other than that, you should be okay. Problem 2 says you got 35 books for summer reading. You're going to choose 1 different book each week. How many different ways can you choose 1 book per week for 6 weeks? Now this is one of those where, again, you have to think, how many choices am I making? I am choosing 1 book per week for 6 weeks. That would be 6 blanks. Now ask yourself on the first blank, how many choices do I have? Well, I have 35 books to choose from on the first week. On the second week, though, I shouldn't have 35 because I already chose 1. What I should have now is 34 to choose from because I already chose 1 book to read. After that, I should be down to 33 because I already chose 1 here and 1 there. I should then have 32, 31, and 30. So again, the first week I have 35, then 34, 33, 32, 31, 30. And again, for your final answer for number of decisions, you simply multiply all those numbers. So 35 times 34, 33, 32, 31, and 30 gives me the answer of a very big number. Looks like 1 billion, 168,675,200. And you don't really need to put the commas, but I just did that so I knew for sure. 1,168,675,200. Yep, that would be how many choices you have for 35 books over 6 weeks. A lot of different choices. But again, the key thing is getting your blanks. There are 7 different forks and 5 different spoons. How many spoon fork arrangements can be made? Think about how many choices I am going to make. I am choosing a spoon. I am choosing a fork. Those are the only 2 choices I am making. I am not choosing 7 forks, 5 spoons. I am choosing 1 spoon, 1 fork. Well, for spoons, or for forks, I'm going to have 7 different choices there. For spoons, I have 5 different choices there, which gives me a total of 35 choices. That's all. Alright? So, taking this a little bit further, whenever you're randomly selecting something, sometimes you have to consider whether you are replacing what's going on. So the question you will ask yourself is, am I putting the item back before choosing again? In this case, in a lot of the cases, in this case, we did not put the fork back because it didn't matter. We're choosing 1 fork, 1 spoon. But in other situations, you might be choosing a marble from a bag, and it makes a difference whether you put that marble back or you do not put that marble back in terms of what your work ends up looking like. So, looking at problem 4, this is your replacement factor that you have to consider. So, 13 red chips, 12 blue chips. How many different ways can you select 2 reds and 1 blue if the chip is not replaced after drawing? So you're talking 2 reds and 1 blue. That means I am making 2 choices here and 1 choice here. That's 3 choices altogether. Well, on your first chip, if I want it to be red, I say to myself I have 13 red chips to choose from. If I did not replace that chip, then I pulled a red chip out, did not put it back. That means now I have 12 red chips left on my second pool, because again I want 2 red chips. So I have one for your 13, one for your 12, and then I want a blue chip, which means that I would choose out of 12. Again, there were 13 red chips to choose from first. I did not put it back, so now there are 12 red chips to choose from, and in the beginning there are 12 blue chips anyway. So multiplying those three numbers gives me the answer of 1872 as the number of ways that I can choose 2 reds and 1 blue. But what if the chip is replaced? Again, taking those decisions and putting them back down. Yes, I have 13 red chips to choose from, but if I put that red chip back, that means on my second draw I still have 13 red chips to choose from. In the end, I will always have 12 blue chips to choose from, and that will give me a different number if I replaced it. So this would be 13, 13, 12, which is 2028. So this is where you have to consider replacement versus non-replacement. Again, notice when I don't replace it that the first selection changed my second selection. When I did replace it, my first selection did not affect my second, and that's what you need to keep track of. Alright? Go ahead and write this, that a factorial is a product of all numbers from n to 1. And its symbol is a exclamation point. So this would be read as 3 factorial, which would be 3 times 2 times 1, which if you type that in, you get the answer of 6. 8 factorial, which is how you read that, is 8, 7, 6, 5, 4, 3, 2, 1, all being multiplied, which is 40,320. This factorial button is actually found under the PRB section of the math menu. So again, you know how to hit the math menu here, but if you look at your menu topics, you have probability stuff over here. So what you can do is you can actually use your arrows, either move to the right, or you can even from here just arrow to the left, and it takes you right over there. You see your fourth option, which means you could push 4 right now, is the exclamation point. So with that said, if we were going to evaluate 11 factorial, all you have to do is type the 11, hit math, move over to your probability menu, select the factorial. Notice it has 11 factorial here, and then your answer pops right up. So 399,16800 would be what 11 factorial is. Or if you would have done 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. It's just that the calculator did it for you because it knew what you were looking for. So outside of that, again, I'm not giving you lesson credit because there's no point. I mean, if you didn't watch the video today, then it's probably going to hurt you later. But other than that, go ahead and go to your Math Excel, start your work, and try to get things done. And again, make sure you are working to know this stuff. Your test is next Friday, so there is no holding that back or getting away from it. We just got to make sure we're ready to knock it out. Good luck.